So I'm Ilya. I will speak about visualizing mobility. This is an example of what I'm working on at the company Teralytics, where I work. Here you see people moving, like how the movement of people changed before and during the Hurricane Irma in Florida. And with yellow, you see that there were much fewer movements in this area. And sorry, with green, and with yellow, you see that people tried to move away from Florida. So in big places, people stayed at home, but some of them tried to move away. Yes, but that's not the actual presentation. Yes. So I've been working with, I'm a data visualization engineer. Louder, louder. I'm a data visualization engineer. That means I'm mostly writing code, which draws something on the screen of a computer. And I've been working with data on mobility for quite a while. I started during my studies. I wrote my thesis about movement of people. Then I joined design studio, Interactive Things in Zurich, where I worked on a couple of projects. Some of them were data journalism pieces, and some of them were about movement of people. Yes, and now I work for a company called Teralytics, also in Zurich, and what we do is we partner with telecom companies. They give us access to data on how people move, and we process it, build models upon it to extract some useful aggregated knowledge. And our customers are mostly mobility services and transportation agencies, which need to know how people move in cities and countries on a large scale to better plan for the extension of their services, or see where they meet the demand or how they could improve. So the data we're getting from telcos, we're getting access to, is some traces of movement for many people. It's anonymous, of course. Our data scientists do some probabilistic modeling and aggregate this data for many people, and we can get some kind of aggregated view. In this case, it's a crowd density or footfall, how many people visited certain locations during a certain time period. How many people, like the color of each hexagon shows how many people visited this location for a certain time frame, during a certain time frame. And privacy is extremely important. We take it very seriously. Something to note is that the data we're getting, as I said, is anonymous. It's also imprecise. We only know which cell tower people were connected to. So it's like a few kilometers in radius. Usually it's also sparse because events are not coming, like they're coming with randomly random intervals, time intervals. And it's noisy. There are many effects like ping pong effect. If you are in an area served by multiple cell towers, then even if you are stationary, you can jump from one to another cell tower. So there are many issues with the data, which the modeling tries to account for. And it also helps, like it also makes it more difficult to identify the people. But that's not enough. We also do aggregation, as I said. K anonymity filtering, that means that like in the numbers we show to customers, we filter, we at least have to show K people, depending on the country, there are different legislations, so that it's more difficult to re-identify individual people. And we also add some probabilistic noise. Like if we know there are two locations, we we don't really know how people travel between those two locations, right? We actually include in the result multiple options with different probabilities, and that adds noise, which also makes it more difficult to re-identify people. Yes, another example of data we can derive from this is also aggregated counts of movement of people between pairs of locations. It's called origin-destination data. You have two locations, A to B, and we can count how many people moved between those two locations. And here with the thickness of the arrow, we show how many people were moving. The thicker, the more people. So OG data can be represented as a table with 3 columns. We have origin, destination, and how many people moved between them. We don't consider the exact routes. It doesn't matter. It's just important how many people moved from A to B. And the most common representation of this kind of data is a flow map, which basically shows with arrows and varying the thickness of the arrows. The thicker, the more people moved. Often OD data comes also with other attributes. We have additional columns in this table, like time, when the movement happened, duration, mode of transport, and can be others. And what kind of questions can be answered by this data? Like overall, where to and from people travel within a region to see the spatial situation. What are the top destinations from a specific location, like where most people go from a specific location? What are peak times, when more people go between pairs of locations, when they travel? How many people travel between a pair of locations at a certain time? If you have a corridor, for example, a bus line, you're planning to add a new bus line. You have a corridor, right? You're planning for a corridor along which people will be traveling, and you want to see, like, what's the current situation, how people travel along this corridor. And if you have mode of transport, you want to see, like, what's the distribution of different modes of transport for people traveling from A to B. Many people travel by car. Maybe we can address this by introducing a new tram line, so they will be not driving by car. And currently, this is not yet an actual product. We are designing it, but we are thinking of trying to actually have the possibility to search for questions people are interested in. Like, we would support a range of questions. People would search for the questions, and then when they pick a question they're interested in, we would show a targeted visualization which would answer this particular question. But our current tool is looks like this, and it's more targeted at not at a general audience, but at more specialist transportation planners who know what OD data is. And this is more of an exploratory tool, right? So we don't show ready answers. You have to dig in, interactively zoom in, select what the area you're interested in, filter to find answers to your questions. And with this tool, the idea is to target a broader audience of users who really want ready answers to their questions. But it's a bit of a challenge to put together a list of questions so that we can support them all and also satisfy the demand of the users. Yes, but with this data, like, in order to visualize it, it can be quite complex, right? So there is a challenge of scalability. We have quite complex data, and the size is also a challenge. Like, you want to be more precise, you want to look at larger areas, right? Then you have more connections, and the more connections you have, the larger the data set. So how to make a visualization which is readable, right, for this kind of data? This is not a super simple task. So the visualization should be scalable by itself. We should be able to represent more data with it, if possible. And if we can support interactive exploration, that can help as well, because we don't have to show all the data at once, right, in all its detail. We can show a meaningful summary first, and then the users will zoom in, filter, and choose the slice of data they are interested in, right? So for scalable visualization, this flow map visualization, which we developed, it actually uses quite a lot of visual techniques in order to make it more readable. So we sort the lines, the arrows, so that the largest are at the top. We fade out the smaller ones, right, so that they are not disturbing too much, distracting too much the attention, because they're mostly noise. We are probably mostly interested in larger ones, but still we want to see which regions are connected, right? We use a blending technique. This is a special rendering technique which makes it sure that we can still read the underlying map to some extent, even if we have a sea of thousands and tens of thousands of lines which cover the map. And then we draw outlines around the arrows so that they don't form like a blob of one color, right, which would make it unreadable. We use WebGL for rendering. That makes like it's one of the free currently available techniques in the browser to draw something, and it's the most performant one, so we can draw more objects with it. And we use adaptive summarization and filtering, so that we don't show all the data in all of the detail all the time. We show some summaries or some subsets of the data as it makes sense, and adapt the view. Until recently, there haven't been too many tools for making flow maps, although it's quite a useful visualization, I think. And the tools which are available they actually are either difficult to use because they are probably not made especially for flow maps, but are more generic, like Tableau. All of those four, actually, they are not made especially for flow maps. They are commercial. Some of them are very expensive, and also, like in particular for flow maps, they are not necessarily scalable. They don't. You can make a flow map with QGIS with tens of lines, right? Although it's quite cumbersome to make it, but if you have tens of thousands of hundreds of thousands, it won't work very well. So for me, part of the motivation of my work is that we can also share what we build with the whole world, and that's why we open source what we are allowed to. So we open source the library to draw flow maps. Anyone can use it, but not that many people use it, because the overlap between the group of people who are interested in flow maps and who can do JavaScript is rather small. That's why I decided to develop a tool which doesn't require programming knowledge, and I did that. It's called FlowMap Blue, and you can easily visualize a flow map if you have OD data with it, and it would look like this. This is an example showing the bicycle sharing data for New York, all 17 million trips in 2018. And to use it, you don't need much. You need a Google account. You need to upload your data to Google Sheets, and then paste the link to Google Sheets in this field, and then you have the map. So the Google Sheets looks like this, the spreadsheet. You need to fill in three sheets. One is properties with metadata, name of your dataset, the source is very important, and some settings like the color scheme. Then the location sheet. Here you put coordinates of the locations which are involved in the movement. And here you have the actual flows. You need to put the IDs of the origin, destination, and then the number of people or whatever is moving, right? And it's quite simple. That's why many people have been using it, and it makes me quite happy. And people uploaded hundreds of data sets from all over the world, visualizing very different things. Not only movement of people, but also other stuff. So this is the Commuters in the Netherlands. This is bicycle hires in London. You can see Hyde Park, very prominent. And the two train stations where commuters are going to and from. This is Waterloo in Canada, I think, where they try to see, like, look at the short rides people take by car, which they could have been could be taken by bicycle, right? So there's some room for improvement, and you understand which routes are most often taken. So maybe there you should put something, improve the bicycling infrastructure somehow to motivate people to cycle. And even some people used it for something I didn't intend it for, like visualizing trajectories of movement. It seems that, yeah, it's also quite easy. They just, instead of putting flows, they just put number of movements between subsequent locations. This blows my mind. It's the sewer system in King County around Seattle. I didn't think that sewer system is also about movement, geographic movement, right? Kanalisation, Abwasserungssystem. Some data sets are quite messy, which people uploaded. This is bus travels in São Paulo, Brazil. Not very readable, right? Australia, also not very useful because Australia is very sparsely populated. This is the relocations in Australia, like how people moved in 5 years from one place to another. And the largest flows are obviously very short and you cannot see them, right? And there are too many locations which are very dense at the same place. It's not very readable. So when I saw such data sets, I started thinking, how could I improve it? And then I stumbled upon this library, Supercluster, which is meant for, not made for OD data, for arrows, right? But for just putting together, if you have many locations in one particular area which are dense, you can group them together, cluster them efficiently. So I thought maybe I give it a try for OD data. And so there are two steps. First, we cluster the locations themselves, and then we aggregate the flows between like the groups of locations. So we have some locations. We start with the largest ones, then cluster, form clusters around those largest ones. Then we group them together into clusters, and then we aggregate the flows, and then we get the new flow map, clustered flow map. So for these two examples I showed you before, there is some improvement, right? So this is much more readable. But we kind of lose some detail, right? We have an overview now. We don't see the individual flows anymore. But the good thing about it is that the clustering is quite fast, so we can do it dynamically while you are interacting with the map. So you zoom in and zoom out, and it will expand and collapse accordingly. So this is what I meant by adaptive summarization of the view. Yes, and yeah, some people found that this feature is actually one of the most useful ones in the tool. So another feature is that you can specify, like we use Mapbox for the base map. It's one of the map providers, like comparable to Google Maps, but more customizable. And you can specify the style of the base map in your spreadsheet for your flow map. And actually, Mapbox, they have a quite cool style editor, map style editor. You can style everything, all the colors, all the labels, whatever. You can also upload data, geographic data, to your style, and it will be shown in the background. So here I uploaded municipalities, Gemeinden, Schweizer Gemeinden. Yeah, and here you don't see it very well, but they are shown there. Like if you just use the normal Mapbox, you won't see them there. And you can even upload some data, showing some numbers, right? So here, this guy wanted to look at correlation between the risk of some epidemic spread and the trading of poultry in Vietnam, right? So the arrow showed the trading of poultry from one place to another, and the color of the map shows the risk of epidemicity. Yes, just a short video showing a few data sets. Maybe it works. Maybe not. Ah, yes, it's coming. I want to put some music in the background, but I haven't done so. Yeah, this is the Commuters in Switzerland dataset. I don't know. Actually, I think I opened the dataset itself. The internet is not so fast. So yeah, I can zoom in and it expands, right? I can also select a particular location, right? So now it's only Zurich. And there's a cool feature, Animate Flows, so we can see animation. So yeah, and of course you can look for particular locations. Like, I don't know, we are in Basel, let's look for Basel. Right, so some people are commuting pretty far. So, but these are the largest commutes, right? So from Rien and Aarschot. Yes, so you can find yourself in this data set. I'm commuting from Milan to Zurich, so somewhere here. So let's try. If you have questions, just go ahead. We have time. No, go ahead. Go ahead. Yeah. You forget maybe. Okay. So yeah, another thing to address the scalability issue is interactive exploration, as I mentioned. So we don't show everything at once. We show some summary or a subset. First, we show a summary, an overview. Visualize, then you form a query in one way or another. Then you visualize the result, and this way you can interactively explore the data or go back to the summary. Yeah, and for datasets with attributes, it's actually quite important because, like here, we have this hour, day, mode of transport, distance, because they grow quite quickly, right? We have only, like this is an example, we have only 100 locations, a few attributes with not so many possibilities, but we get 1 billion rows in the database, which is quite a lot. Like if you use a conventional relational database like Postgres, that's too much to get interactive response times in a few seconds. This might be too technical. Do people understand what SQL is, or should I skip? SQL, who knows what SQL is?
No, I don't know.
No, I'll skip. It's just a way to query a database, like I showed an example query, which we need for our dataset, and we need to ensure that it's responsive, so that it's fast enough. So we had to look around what database we could use. We found ClickHouse, which is not very well known, but it's quite good, working well for us. And it's faster than conventional row databases like Postgres for a couple of reasons. And it scales, like we can add more machines to our database cluster, and it will respond to queries faster. And there is this guy just did the comparison of a number of datasets, number of databases trying to respond to queries for 1 billion taxi rides in New York, and ClickHouse performed quite well. So yes, and we actually open sourced a prototype tool which is similar to FlowMapBlue, which I showed before, but it also has this ClickHouse database in the backend, so that you not only see the flows, but you can also have attributes and query them efficiently. And it's open source. But it requires some more work to set it up and some technical knowledge at the moment. Maybe we'll improve. Yeah, because it needs a database, right? Somebody has to set up this database. That's pretty much it. So these are the tools, links to the tools which I showed. FlowMapBlue is the one for non-technical people. We are looking for designer, interaction designer, and a front-end engineer. And I can show you something experimental if YouTube cooperates. Yes, this is an experimental visualization of the same Commuters dataset, but in pseudo 3D. These are like stars and stellar movements, stellar commutes. That's it, if you have questions.